Assalamu alaikum wa rahmatullah. Dear students, this is the 10th lecture as far as the polymer chemistry is considered. In this video lecture, we will discuss an important topic, and that is copolymerization. During the classification, we have discussed two types of polymers. One is homopolymers, and the second is copolymers. If I will tell you what is meant by homopolymers, polymers obtained from the same monomeric unit. For example, if you have the ethene, if it is subjected to polymerization, what you get the polythene. This is polythene. We have discussed it. Pi bond undergo breakage. Valence is being created at this carbon, and at this carbon they form the bonds, and you get the polythene. This polythene is a homopolymer because it is made up of only one type of monomeric units. When the polymer is made up of only one type of monomeric units, it is known as homopolymer. But here we have to discuss copolymerization. We have to discuss copolymers and how you can define the copolymers. If you have the butadiene, we have already discussed this type of polymer also. If you have butadiene, this is 1,3-butadiene. 1, 2, 3, 4. It is buta 1,3-diene. If it is made to undergo polymerization with styrene, for example, what is the structure of styrene? This is styrene. Remember this point. This is styrene and this is buta 1,3-diene. If these two monomeric units are allowed to undergo polymerization, and in presence of sodium I have already mentioned that it is polymerizing agent. It is polymerizing agent. It helps, it increases the rate of polymerization. Remember this point. If these two, buta 1,3-diene and styrene, they are allowed to undergo polymerization, you get a polymer. But that will be a copolymer, because that polymer will be obtained from two different monomeric units. What will be the polymer here? I have already mentioned the mechanism. Pi bond will shift from this position to this. It will shift it here. It means that there will be a bond formation between this carbon and this carbon. It will be shifted here. It means that this carbon will form bond from this side. This carbon will form bond from this side. You get a polymer. What will be that polymer? CH2, single bond. Now we have double bond here, CH double bond CH. Here it will be the single bond. You will have CH2. It will form bond with this CH2. Remember this point. And you will have CH. We will have bond, and here we have the benzene ring. Remember this point. This is the polymer, and this polymer is a copolymer. Now what is meant by copolymer? When two or more different monomeric units are allowed to undergo polymerization. Here we have two. You can polymerize more than two. Monomers can be two types or they can be more than two types, and the resulting polymer is known as copolymer, and the process and the polymerization is known as copolymerization. Dear students, what will be the name of this polymer? It is styrene butadiene copolymer. This is styrene butadiene copolymer. Remember this point. And it is a kind of rubber. This rubber is commonly known as Buna S. Buna S. The Bu, it stands for butadiene, and Na, it is the polymerizing agent, and we have the S, that is the styrene. In simple words, you have to mention, and we have already mentioned it, how you can define the copolymerization. It is the polymerization in which two or more different monomeric units are allowed to undergo polymerization. This is the first point you have to mention. For example, this Buna S, it is a copolymer obtained from butadiene, and we have the styrene. This is the first point you have to mention here. How you can define the copolymerization? You can mention it is the type of polymerization. This is the first point. It is the type of polymerization. It is the type of polymerization in which two or more different. This is the first point. The definition: two or more different monomeric units. Two or more different monomeric units. Two or more different monomeric units are allowed to undergo polymerization. To undergo polymerization. This is the first point. It is the definition. How you can define copolymerization? It is the type of polymerization in which, this is the point you have to mention, two or more different monomeric units are allowed to undergo polymerization. The resulting polymers are known as copolymers. It means that in this very topic we have to discuss certain important things about the copolymers. The process is known as copolymerization, and the polymers are known as copolymers. Remember this point. Now we discuss certain important points regarding the copolymers. Dear students, these copolymers, they can be formed. They can be either addition copolymers. This is the second point you have to remember in this very topic. The first, you have to remember the definition. The second, the copolymers can be either addition copolymers. What is meant by addition copolymers? These are obtained by addition polymerization. Simple addition of monomeric units. Copolymers can be also condensation copolymers. It means that copolymers are of two types. One is addition copolymers obtained by addition polymerization, and we have the second, condensation copolymers. And how you can define the condensation copolymers? These are obtained by condensation polymerization. In the previous lectures, we have discussed the addition polymerization, and we have discussed the condensation polymerization. Remember this point. On the basis of mode of mechanism, whether it is addition polymerization or it is condensation polymerization, these copolymers are of two types. We have addition copolymers, and we have the second, that is condensation polymers. We will take the examples of both these two. Example of addition copolymer, how copolymer is formed by addition polymerization, and how copolymer is formed by the condensation polymerization. This is the second point you have to mention. You have to mention copolymers. Now we'll talk about the copolymers. Can be formed, can be obtained either by addition, also known as chain growth polymerization. We have discussed these things already. Chain growth polymerization. Copolymers can be obtained either by addition or chain growth polymerization. At that time, what will be the name? At that time, these are known as addition copolymers. At that time, the copolymers are known as addition copolymers. This is the first type. Or They can be also obtained. They can be also obtained. They can be also obtained by condensation. We have discussed these types already. Condensation or step growth polymerization. We have discussed these two: addition polymerization, condensation polymerization. It is also known as step growth polymerization. At that time, what will be the name of the copolymer? It will be condensation copolymer. Condensation, you will have copolymer. Condensation copolymer. Condensation copolymer. This is the second point. First, you have to know the definition. We have discussed that. Now, the second point, you have to discuss copolymers can be either addition copolymers. They can be either condensation copolymers. Now, we'll take the examples. We have already discussed a number of examples, but I will repeat here many more examples. Let us take examples. Examples. You can say, for example, you can mention examples. We'll take the example of addition copolymer, and you can take the example of condensation copolymer. Dear students, if you take the example of Buna S, we have discussed Buna S. You can remember Buna S is an addition copolymer. This is the first point. I will take this example, Buna S, butadiene styrene rubber. Buna S is a kind of synthetic rubber. It is addition copolymer. I will now mention the reaction. You have butadiene. This is butadiene, buta-1,3-diene. This is one monomeric unit, n times, because there is polymerization. What will happen? Plus, you will have n times styrene. N times styrene. In presence of polymerizing agent, that is sodium. Remember this point. This is buta-1,3-diene. Buta-1,3-diene, and we have the styrene. Remember this point. When these two, buta-1,3-diene and styrene, these are two different monomeric units, and when these are allowed to undergo polymerization, you get a copolymer. What will be the mechanism? Simple mechanism: shift of pi bond here. There will be bond formation between these two. There will be shift of bond. It means that this carbon and this carbon will form bond, as already mentioned. CH2, CH double bond CH. You will have CH2. It will form bond with this one, CH2. We have single bond CH. You will have here benzene ring. This is the copolymer, and what will be the name? It is styrene butadiene copolymer. I have already mentioned the name. What will be the name of this copolymer? Butadiene styrene copolymer. Styrene copolymer. When we discuss the synthetic rubbers, it will be the first type of synthetic rubber, butadiene styrene copolymer, and it is commonly known as Buna S. I have already mentioned. Bu stands for butadiene, S stands for styrene, and Na, it is polymerizing agent, that is sodium. It means that Buna S, it is an addition copolymerization. And what is the necessary condition for addition polymerization? The monomeric units, they must contain multiple bonds, double or triple bonds. Remember this point. When the monomeric units contain double or triple bonds, at that time, they can be made to undergo addition polymerization, and here it is addition copolymer. Remember this. Now I will take the example of condensation copolymer. I will take the example of condensation copolymer. For example, we have nylon 6,6. We have already discussed its preparations, properties. Here I will repeat what is the reaction and what sort of polymer it is. Nylon 6,6. You have to mention first. It is condensation. What is meant by condensation? When two monomeric units combine to form the product, to form the polymer, along with the elimination of some small molecules like water, like methyl alcohol, like HCl, like ammonia. And what is the necessary condition for condensation polymerization? The monomeric unit should be either bifunctional, they should contain two functional groups, or they should be trifunctional, they should contain three functions. We have discussed these things. Here I am repeating, I am telling it again. We have condensation copolymer. Nylon 6,6 is a condensation copolymer. Now we will see how the nylon 6,6 is obtained. It is obtained by the polymerization of, you know, what are the starting monomeric units. We have adipic acid and we have hexamethylene diamine. We will see how it is being prepared. You have adipic acid. This is adipic acid, CH2. You have CH2. We have 4 times C double bond OH. You will have C double bond OH. This is the way. C double bond OH, C double bond OH. It will be N times. This is adipic acid. Adipic acid, dicarboxylic acid. It is adipic acid. Around this point, it has 6 carbon atoms, 4, 5 and 6. This is adipic acid. We have hexamethylene diamine. We have already discussed it. Hexa, it will be 6 times diamine. NH2, we have NH2. This is the way. It will be also N times. Now tell me what will happen here. It will be condensation. There will be condensation. OH will come out in the form of water. Remember this point. You will see here minus twice N minus 1 water. I have already mentioned why it is twice N minus 1. If 2 combines, 1 water molecule will be come out. If 10 monomeric units combine, 9 water molecules will come out. It means that number of water molecules will be always less by 1. Remember this point. It is hexamethylene diamine. Hexamethylene diamine. Hexamethylene diamine. When they undergo polymerization, it is OH will come out, H will come out from this, and you get a polymer. What sort of polymer you will have? C double bond O, CH2, 4 times, C double bond O. It is amidic linkage here. You know nylon 6,6 is polyamide, is a polyamide. You will have CH2 whole 6 NH. This is N times, and this polyamide, it is known as nylon 6,6 because why 6,6? We have discussed these things already because both the monomeric units contain 6 carbon atoms each. Hence it is known as nylon means polyamide, and since both contain 6 carbon atoms each, hence it is known as nylon 6,6. And it is clear it is a copolymer, but it is obtained by condensation polymerization. When 2 combine, you get the product along with the elimination of some small molecules. And this nylon 6,6, it is a condensation copolymer. You have to remember, this is the second point. Copolymers can be either addition copolymers or they can be addition condensation co. This is the second point. Addition, they can be addition copolymers or they can be condensation copolymers. Remember this point. Now we'll discuss the composition and properties of copolymers. We'll discuss the composition and properties of, this is the third point you have to mention. Composition and the properties. Composition and properties of copolymers. You have composition and properties of copolymers. Remember this point. The first point, we will discuss the composition. If you have the DUNA-S, you have the butadiene styrene rubber. I will repeat the example so that you will get it in a better way. You have butadiene. This is styrene. Around this point, styrene. N times you will have the Buna S. What will be the Buna S? Now you know. Pi bond will shift here. You will have double bond here. Single bond CH2, CH2. You will have CH and you will have. This is Buna S. I am repeating this point. It is Buna. Remember this point. A copolymer. This copolymer, it contains the composition. It is made up of both the monomeric units. Copolymer contains large number of units of both the monomeric. It means that this copolymer contains large number of butadiene in the polymeric chain. It also contains large number of styrene units in the polymeric chain. You know, during the polymerization, first you get the polymeric chains, then they come close to each other, you get the polymer. It means that in a copolymer, each polymeric chain, for example, this is the polymeric chain, contains large number of units of this butadiene, large number of units of this styrene. This is the first point as far as the composition is considered. The copolymer contains large number of units of both the combining monomeric units. Large number of this one, large number of this one. This is the first point you have to mention as far as the composition is considered. You have to mention this first point. A copolymer will contain, this is the, we are talking the composition, what lies inside the copolymer. A copolymer contains large number of units of the combining monomeric units. Large number of units of combining monomers. A copolymer contains large number of units of the combining monomers in the polymeric chain. It means that the polymeric chain in a copolymer contains large number of units of this monomeric unit, large number of units of this monomeric unit. This is the first point. Second point you have to mention, the composition of a copolymer not only depends upon the relative proportions of these, how much these are present, how much butadiene is present, how much styrene is present. Remember this point, this is composition. I am talking about the composition of this copolymer. This is the important point, but the difficult point you have to understand. The composition of copolymer, it not only depends how much butadiene is present, how much styrene is present. It does not depend upon only the relative proportions, but also depends upon their reactivities. For example, if you have 2 quintals of butadiene, but it is less reactive, it does not react. At that time, it will be formed to a small extent. If you have large amount of styrene, but it is less reactive, it is highly stable, it means that it does not undergo polymerization. For copolymerization, they should be also reactive. It means that the composition of a copolymer depends upon 2 things. The first is proportion and the second is their relative reactivity. They should be reactive. If they are not reactive, what happens at that time? At that time, the composition, at that time, copolymer will be formed to a smaller extent. This is the second point you have to mention. The copolymer, the composition of a copolymer, not only depends upon, this is the second point you have to mention, not only depends upon relative proportions. I mean to say how much they are present. Relative proportions of monomeric units. Relative proportions relative proportions. This is the first point. Relative proportions of monomeric units. Relative proportions of monomeric units. Monomeric units. But also depends upon their reactivities. From this, what you can conclude, the composition of a polymer, how much it will be formed, it depends upon relative proportions of monomeric units, and its composition also depends upon their reactivities. They should be reactive. If they are less reactive, at that time the copolymer will be formed to a smaller extent, although their amounts will be large. It means that for the composition of copolymer, two things are necessary, two things are important. One is the proportion should be high, monomeric unit composition should be high, and they should be also reactive in nature. Remember this point. Now we'll talk about the second important point, properties of a copolymer. This is what about the composition. You have to mention two important points regarding the composition. Now we will talk about the properties of a copolymer. Properties of a copolymer. Properties of a copolymer. I will take the example again to understand the properties. If you have the butadiene, this is the famous example now, and if you have the styrene. You have the styrene, butadiene, and we have the styrene in presence of sodium. Remember this point. And you get the Buna S, butadiene styrene rubber. I am repeating this example. Now it is familiar to you. You know it in a better way. Hence I am repeating it again and again. It is Buna S. Remember this point. This is Buna S, butadiene styrene rubber. The properties of a copolymer are entirely different. The properties of a copolymer, the first point, the properties of Buna S will be entirely different from the homopolymers obtained from the respective monomers. For example, if you want to get a homopolymer of butadiene, you will get polybutadiene. Butadiene. This is homopolymer. If butadiene is allowed to undergo homopolymerization, you get a poly. This is the homopolymer of this one. In the same way, if it is allowed to undergo homopolymerization, homopolymerization means when you have only one type of monomeric unit, at that time you will have polystyrene. Styrene, one point. This is the homopolymer of butadiene, this is the homopolymer of styrene. If you compare the properties of Buna S, this is a copolymer, it has entirely different properties from those of polybutadiene and from those of polystyrene. It means that its properties will be different. It's a copolymer. Its property will be different from the polybutadiene, and it will have different properties than those of polystyrene. But you have to remember one point here. Its properties, in fact, actually the copolymer has better physical and mechanical properties. This one, copolymer, has better physical and chemical properties than mechanical and physical properties than those of polybutadiene and styrene. Remember this point. It means that its usage is important as compared to polybutadiene, polystyrene. It is important, more important than polybutadiene and polystyrene. Hence, we allow these monomeric units to undergo polymerization. We know the copolymer formed will have better physical and mechanical properties than either polybutadiene or polystyrene. This is the first point you have to mention. The properties of a copolymer are entirely different from the homopolymers. This is the homopolymer of one monomeric unit. This is the homopolymer of another monomeric unit. This one will have different properties than this homopolymer and this homopolymer. But you have to remember, it has better physical and mechanical properties than the homopolymers. This is the first point here as far as the properties are considered. The properties of a copolymer, the properties The properties of a copolymer are entirely different than the homopolymers than the homopolymers obtained from the respective monomeric units. Obtained from the respective monomeric units. But you have to remember here, in fact, copolymers have better physical and mechanical properties. You have to mention this point. They have better physical and mechanical properties than those of homopolymers. It is just like alloying in the metallurgy. In metallurgy, you have the alloys, homogeneous mixture of metals. Why we allow the metals to combine, to undergo alloy formation? Because we know alloys have better properties than the respective metals. Same way, why we allow the styrene to copolymerize with the butadiene? Because we know the copolymer have better properties than either styrene and the butadiene. This is the second point. Copolymerization is just like alloying. This is the second point you have to mention. Copolymerization is just like alloying in metallurgy. We undergo alloy formation. We go through this alloy formation because we know alloys have better property. We combine iron plus copper, you get the alloy, because we know alloy has better properties than either iron and copper. Similarly, why we go copolymerization? Because we know copolymers have better properties than either the monomeric unit. This is the second point. Copolymerization is just like alloying in the metallurgy. You can also mention, just like alloys have better properties than the respective metals, in the same way copolymers have better properties than the homopolymers obtained from the respective monomeric units. Remember this point. It means that we go through this copolymerization because we know copolymers have better properties, physical and mechanical properties, than the homopolymers obtained from the combining respective monomeric units. Now you will mention here types of copolymers. You can mention types of copolymers. Copolymers are of following four types. The first one, alternating copolymers. It means that when the monomeric units are present alternatively, let us say you have this one, this is alternating copolymer. It's a copolymer because we have two different, but when the monomeric units are present alternatively, at that time it is known as alternating copolymer. You can mention in this type, A stands for one monomeric unit and B is another monomeric unit. They are present alternatively. In this type, monomeric units are present alternatively, in the polymeric chain. in the polymeric chain. When this is the arrangement, at that time it is known as alternating copolymers. The second, we have random copolymers. Random copolymers, when the monomeric units are present or randomly, that type is known as random copolymers. Random copolymers. For example, we have this one, A, B, A, B, B, A. When they are present randomly, around this point, when they are present randomly, it is random copolymer in this type. In this type, monomeric units are present randomly. Monomeric units are present randomly in the polymeric chain. In the polymeric chain, it is random copolymers. Remember this point. Now we have the third type, that is block copolymers. We have the third type, block polymers, block copolymers. Block copolymers. What happens here? We have blocks of each monomeric unit. For example, we have block of, this will be the arrangement. Then we will have block of another monomeric unit. This is the way. This is block of one monomeric unit, this is block of another monomeric unit, and then when this is the arrangement, at that time it is known as block copolymers. In this type, there are blocks of each monomeric unit, each type of monomeric unit, blocks of each type of monomeric unit, monomeric unit, block of each type of monomeric unit in the polymeric chain. This is the third type, that is block polymers. Now we have the graft polymers. We have the fourth type of polymer, that is graft polymers. Graft copolymers. In this type, it consists of a linear chain, polymeric chain of one monomeric unit. For example, we have this one. It consists of a linear polymeric chain of one monomeric unit, from which branches of another monomeric unit gets developed. Grafting means branching. There occurs branching. You have linear chain of one monomeric unit, and from the linear chain branches get developed, and when this is the arrangement, at that time it is the graft copolymers. You can mention it consists of I'm talking about the graft copolymers. It consists of linear polymeric chain of one monomeric unit, one linear polymeric chain of one monomeric unit, from which branches are grafts. You can say branches are grafts of another monomeric unit. Another monomeric unit get developed. Monomeric unit gets developed. It means that how many types of this copolymers we have? We have four types of copolymers. One is alternate. The second is randomly. They are randomly arranged. The third is we have blocks of monomeric units A. Then we have BB, and then we have the graft copolymers. This it was the important topic, that is copolymers, the composition of copolymers, and we have the properties of copolymers. You have to mention the copolymers have better physical and mechanical properties than those of the individual homopolymers. Hence, we go through this copolymerization. It is just like alloying in metallurgy. Inshallah, we discuss the remaining things, inshallah, in the next lecture. Till then, fi amanillah.